Here's problem 2510. Identical 2 microcoulomb charges are located on the vertices of a square with sides that are 2 meters in length. Determine the electric potential relative to 0 at infinity at the center of the square. Alright, so let's visualize what we have here. We have a square. And at the corners of each, or the vertex, we have charges, equivalent charges. And they're all equal to 2 microcoulombs. So let's call this Q1, Q2, Q3, Q4. We want to find the potential relative to 0 at infinity at the center of this square. Let's call that point A. Now, we know that potential goes as kq over r. In this case, we have positive charges, and they're all going to be located the same distance away from point A. So they're all going to contribute the same amount to the scalar potential at point A. So what we really need to do is just find the contribution from one of these charges and then multiply it by 4. We need to know, though, how far away one of these charges is from point A. So if I look at half of this distance, we're 2 meters on a side, so this distance here will be 1 meter, and this distance here will also be 1 meter. So the distance of our hypotenuse here of a right triangle is going to look something like this. And 1 meter here, 1 meter here, right triangle. So the distance C is going to equal 1 squared plus 1 squared square root, which is the square root of 2. So our distance R from one charge to the center of the square is going to be the square root of 2. Hence, our potential due to one of these charges, say kq1 over r, is going to be equal to 9 times 10 to the 9 times 2 microcoulombs over the square root of 2. So that is going to be equal to, if I can find my calculator, 1.27 times 10 to the 4 volts. Since all 4 of these are contributing the same amount, the potential at A is going to be equal to 4 times the potential from one of these. So that's going to be 4 times this 1.27 times 10 to the 4. And that will give me 5.09 times 10 to the 4 volts. Or we could say 50.9 kilovolts is the potential at the center of this square. Now, we want to do this with relative to something. We always have to have a potential relative to something, same way that we would have a height of a hill relative to some zero ground level or zero level that we choose. So in this case, we're choosing infinity, and we would notice in general that the potential of a charge at infinity, where r approaches infinity, would be 0. So our point B, infinity, is 0, and hence the difference in potential between our point A and that point will still be 5.09 times 10 to the 4 volts. So the idea of relative to 0 and infinity just means that whatever potential we get at this point is going to be the electric potential relative to 0 at infinity.